Siddharth, Udayan. Yeah. Okay. So basically, after a long time, we are going to start a new chapter. So, like I told you in the last lecture, that periodic table का थोड़ा सा part बचा हुआ है. दो session में we are going to complete that. But in parallel, we'll be starting because requirement भी आ रही थी कि gaseous state में difficulty आ रही है. कुछ लोगों का already currently it is a running chapter or it is almost over or over है ना. And that's why what I thought ना कि वो थोड़ा सा theoretical चलेगा that track periodic table and उसके बाद उसी में same track में we'll be starting the chemical bonding also. And each track में it will be a numerical वाला track like gaseous state will be doing. Within that gaseous state कुछ बच्चों ने बोला idiometry में difficulty आ रही तो I'll cover that section in this chapter itself. ठीक है. So idiometry I'll cover that. उसके बाद फिर we'll start the thermodynamics and thermochemistry वाला part in this track. So we are planning to have two tracks. In future if you get time common slot अगर मिलता है तो I'll start the third track also. Not right now, but in few days or few months, definitely we have to start the third slot so that we can complete the syllabus on time also. ठीक है. तो ये एक जर्नी अपनी रहेगी. गैस स्टेट में I'll just show you what is officially written in the syllabus. 1 minute. Let me see. Yeah. So if you see the syllabus, मेंस का भी आई हैव रिटन, एडवांस का भी आई हैव रिटन. तो मेंस में तो बहुत ज्यादा इलाबोरेटेड लिखा हुआ है. Almost everything is written there. There are some limitations. Basically, like if you see kinetic theory of gases, it says we have to know only postulates, but just after that, it is talking about average, root mean square, and most probable speed, है ना. तो बहुत ज्यादा मतलब that says कि don't go into that derivation वाला part because that is already the part of the physics, है ना. Physics में when you go to heat and thermodynamics ना, you'll again be taught the gaseous state, ideal gas equation related graphs, and then KTG, kinetic theory of gases. ठीक है. So that's why they have avoided it in the chemistry की बहुत ज्यादा syllabus को detail नहीं करना है. हाँ, राइट नाउ करंट सिलेबस आया नहीं है, बट जैसे आएगा मैं तुमको अपडेट कर दूंगा कि द करंट सिलेबस हैज ऑलरेडी कम. बट राइट नाउ वट एवर वॉज फॉर द प्रीवियस ईयर दैट आई एम गिविंग. ठीक है. तो इन दैट पार्ट एक तो ये पार्ट इंडिकेट करना था, बाकी सब एवरीथिंग इज कवर्ड इन द सिलेबस. इफ यू सी द एडवांस का सिलेबस, गैस लॉज, आइडियल गैस इक्वेशन, टेम्परेचर का फंडा, डेविएशन फ्रॉम आइडियलिटी का मतलब वॉन डर वॉल इक्वेशन. देयर आर मेनी रियल गैस इक्वेशंस. द ओनली थिंग विच इज इन योर सिलेबस इज वॉन डर वॉल्स इक्वेशन. ठीक है. दैट्स अनदर पार्ट. केटीजे लिखा ही है. एवरेज, रूट मीन स्क्वायर एंड मोस्ट प्रोबेबल स्पीड सब लिखा हुआ ही है. ठीक है. लॉ ऑफ पार्शियल प्रेशर का मतलब डाल्टन्स लॉ ऑफ पार्शियल प्रेशर इट इज टॉकिंग अबाउट. डिफ्यूजन ऑफ गैस इज देयर. नाउ इफ यू सी एक दो चीजें और मैं इंडिकेट कर देता हूँ. Like this is a common chapter in physics and chemistry. Okay, so there are few things which are also in physics, like KTG. I told you ideal gas equation, KTG, and that ideal gas equations related word problems and the graphical problems. Okay, but the real gas equation, real gas and its equation is not in the physics का syllabus. Diffusion of gas is not in the physics का syllabus. ठीक है. ये intermolecular interaction ये तो एक table है that we'll talk about at the end of the chapter. So these are the things which are not in the syllabus. So probability of asking the question is more from this section in chemistry. Okay, so we need to understand the psychology also. If जो question setter है ना वो भी सोचता है कि what is not common in physics and chemistry that should be asked in the chemistry, and it is a tradition also. If you see, like I told you earlier also, जिन्होंने atomic किया है already, that Bohr's model is common in physics and chemistry. तो देखोगे physics में Bohr's model के questions आते हैं. When they come to chemistry, they start asking about the latest model, जिसमें हम लोगों ने quantum numbers की बात की थी, Schrodinger wave equation के solution की analysis की बात की थी, है ना. All those concept of orbitals की बात की थी, shape of orbital, energy of orbitals, ये सब की जो बात की थी ना, they are asking the question from that section in chemistry because that is not the common section. Okay, तो ये चीज हम लोग आगे भी फ्यूचर में देखेंगे. थर्मोडाइन हीट एंड थर्मोडाइनमिक्स जैसे फिजिक्स में चलेगा, विल बी लर्निंग हियर थर्मो केमिस्ट्री एंड थर्मो डायनेमिक्स. तो देयर आर सम सेक्शंस कॉमन. अगेन आई विल टेल यू, वहां पे पढ़ना तो सब कुछ है. वॉट एवर इज रिटन इन द सिलेबस वी हैव टू स्टडी एवरीथिंग, बट those sections from the revision point of view, those sections become more important which are not common in physics and chemistry, and that becomes important in chemistry. Okay, आज का क्लास बहुत ही बेसिक से होगा। पीवी इक्वल्स एनआरटी कितने लोगों ने सुना है? पीवी इक्वल्स एनआरटी। ओके, निरंजन, प्रत्युष, श्रेयान, ओके, अंशुल ने भी सुना है ऑलमोस्ट। मतलब ये आया है वो मोर 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 कंसेप्ट में तो कहीं ना कहीं से यूज करना ही पड़ता है, उसके बिना ना वेपर डेंसिटी का कंसेप्ट हो पाता है ना मोलर वॉल्यूम एट एनटीपी एसटीपी, इन सब की बात ऑलरेडी होती है। बट आई विल स्टार्ट फ्रॉम दैट पॉइंट ओनली। बहुत ही बेसिक से स्टार्ट करते हैं, आइडियल गैस इक्वेशन से ही स्टार्ट करेंगे और उसके बाद फिर डिटेल में जाएंगे। उसके पहले बहुत ही छोटा सा बेसिक पार्ट कर लेते हैं। व्हाट इज यूनिक अबाउट अ गैसियस स्टेट व्हिच इज नॉट इन सॉलिड और लिक्विड स्टेट? तो व्हेन वी टॉक अबाउट गैसियस स्टेट वर्सेस अदर स्टेट्स ना, तो फर्स्ट थिंग इज गैसियस स्टेट हैज द मैक्सिमम इंटर पार्टिकल डिस्टेंस, है ना। द पार्टिकल्स के बीच का डिस्टेंस इज वेरी लार्ज, देन वी स्टार्ट कॉलिंग इट गैसियस स्टेट। उससे थोड़ा स्मॉल हो गया तो फिर हम लोग उसको लिक्विड स्टेट बोलते हैं। If it is extremely small, then we start calling it solid state, है ना। Least यहाँ पे when I am talking about distance, it was maximum. When I am talking about force of attraction, it is minimum. Okay. Maximum volume of state for given mass, like if I am having any gas like CO2 gas is there, if I solidify it, it will have very small volume in the solid state, but at the under the same condition of temperature and pressure, if I am having the CO2 in the gaseous state, it will have a large volume, है ना? So that's why I've told you that it is having maximum volume of state for a given mass, and obviously particles are having very high kinetic energy. That's why they are leaving the liquid surface, they are present in the gas state. Shape wise, it is having indefinite shape, like liquid state is also having indefinite shape. This container mein daloge, it will take the shape of that container only, है ना? That's the meaning of having indefinite shape. Approximately zero value for the ratio of volume occupied by particles to the volume of state. Like if I am having in your room only, there is air, and air के particles को अगर पकड़ के इकट्ठा कर लिया ना, the volume occupied by that aggregated particles ना will be extremely small than the volume of the complete room, है ना? Because particles are very small, extremely small, and they are occupying a large volume. That means they are moving in a large volume available. And that's why when I'm saying volume of state, whenever we'll talk about uh, gaseous particles ka volume, then we are talking about volume state, and it implies the volume of container in which gaseous particles are placed. Okay, so volume of particles are very small, but volume state means whatever container you have taken to place the gas inside it, that container ka volume will become the volume of the state. Is it okay? Clear है ना? Any doubt? Now we are going to start with the ideal gas and ideal gas equation. But उसमें एक बहुत ही basic assumption है that we need to understand, and after that we'll see that कि what was that ideal gas equation. When I'm talking about ideal gas, पहली बात, जब जब syllabus में ideal word आएगा, understand that this is a hypothetical concept. Ideal करके कुछ होता नहीं है ना तो science में ना life में, ठीक है? So whenever we are going to talk about something ideal, like in this chapter we are going to talk about ideal gas. Similarly, in 12th class there is a chapter called solution and colligative property. वहां पे we will be talking about ideal solution. वहां पे भी देखोगे मैं बोलूंगा कि आइडियल का मतलब है हाइपोथेटिकल, इट इज नॉट पॉसिबल प्रैक्टिकली, सो देयर विल बी सम एक्सट्रीम assumption in that. Okay, so what is that assumption when we are talking about ideal gas? The assumption is that there should not be any intermolecular force of attraction at all, and that's why देखो बुक में क्या लिखेगा, अप्रोक्सीमेटली, जैसे ही हम लोगों ने आइडियल बोल दिया, it should be exactly zero interparticle. Why I'm writing interparticle? Normally book में लिखा रहेगा intermolecular, because gases can be molecules, gases can be atoms also. Atoms के बीच में intermolecular force बोलना थोड़ा English के point of view से wrong है, ठीक है? Practically we use that, but English के point of view से थोड़ा सा wrong है, because you can have a helium gas का sample. अब उसमें intermolecular molecule तो है ही नहीं, intermolecular force of attraction क्या होगा? And that's why I've just revised it, but in future हो सकता है मैं भी frequently I'll be using the word intermolecular force of attraction. Understand that I am talking about interparticle force of attraction. Okay, so that should have zero interparticle force of attraction, and that the second assumption is it should have exactly zero volume of its particle, or the size of the particle has been assumed to be zero. The moment I say volume of the particle is zero, that means in that extreme situation we can say that the volume of state is equal to volume available for the free motion of particle, and which is the complete volume of the container. Is it okay? whatever I told you this much, it is okay ना, कहीं भी doubt रहेगा, be very frank, क्योंकि इसकी connectivity आएगी. This chapter will be connected to thermodynamics and thermochemistry, and that will be connected to most of the chapter. Okay, because this is the basic science we are going to use in every chapter, almost every chapter, and that's why यहाँ से जो डैमेज होगा वो हर चैप्टर में डैमेज करेगा इन द फिजिकल केमिस्ट्री मोस्ट ऑफ द टाइम. ठीक है. सो वेर एवर यू आर हैविंग एनी डाउट, इफ यू फील दैट नहीं, एक वर्ड भी इफ आई एम नॉट क्लियर, जस्ट आस्क, डोंट हेजिटेट इन आस्किंग योर डाउट. ठीक है. बिकॉज इफ यू आस्क मी, आई विल मेक यू अंडरस्टैंड, दैट गारंटी आई कैन गिव. ठीक है. सो क्या करने का, वेर एवर यू आर नॉट क्लियर अबाउट एनी पर्टिकुलर पार्ट, जस्ट आस्क इट ना. अगर रिलेवेंट नहीं रहेगा तो सर विल टेल यू कि देखो रिलेवेंट नहीं है, या फिर इतना जानने की जरूरत नहीं है, या फिर डेप्थ में जाने की जरूरत नहीं है, दैट आई विल टेल यू. बट डोंट पुट एनी फिल्टर इन योर माइंड एंड द माउथ, है ना. वेरेवर यू आर फीलिंग कि ये डाउट आ रहा है, तो यू हैव टू आस्क. ओके, सो दिस वाज assumption. Now after knowing the assumption, what is the ideal gas equation? Already I told you. Ideal gas equation का मतलब है PV equals nRT. So when I say PV equals nRT, T is temperature in Kelvin. We need to be very careful about the unit of temperature. Whenever in future in your syllabus capital T is written where it is representing the temperature, it has to be in Kelvin. Okay. So T, capital T is always in Kelvin. In future I will tell you the difference in temperature if you take now, so then that will have same value in Kelvin and degree C. Like I'll give you an example, यहीं पे दे देता हूँ मैं. फ्यूचर में तो इसको डिस्कस करेंगे. मान लो if I say T1 is equal to 0 degree C. You know the conversion of degree C into Kelvin? How much we should add?
273.
273.15 to be very exact. Practically हम लोग 273 लेके चलते हैं. If I say the another temperature T2 is 25 degrees C, then what will be the temperature in Kelvin?
298.
298. Okay, very good. Now, if I ask you the difference in temperature in Kelvin, तो difference in temperature को हम लोग delta T से represent करते हैं. If I ask you in degree C, बताओ, how much we are getting? 25. And if I ask you, नहीं delta T तो हम लोग normally Kelvin में लेते हैं, so Kelvin में बताओ, then what is the difference?
25.
25 again. And that's why we are saying that if in future we have to use some formula in which we have got delta T and they have given you the temperature in degree C, even if you take the difference in degree C, na, so there is no worry, there is no problem, there is no mistake. Hai na? We can directly use that. So that's why we can write delta T in degree C is same as delta T in Kelvin. कभी कभी डिग्री सी वाले को स्मॉल टी भी लिख दिया जाता है, बट अभी के लिए मैंने कैपिटल टी लिख के रखा है. सो डिफरेंस विल बी सेम. बट टी इन डिग्री सी या फिर टी इन केल्विन इज इक्वल टू टी इन डिग्री सी प्लस 273.15 to be more exact, but practically we'll be taking T in degree C plus 273. Any problem up to this point? R is a gas constant. इसकी बात हम लोग करेंगे आगे, in detail में करेंगे, because it can have different values in different units. This can also be called universal gas constant. Okay. N is moles of particles. जो mole concept में पढ़ा है, that says moles of particles निकालने के there can be two ways. It can be total mass upon molar mass. Is it okay? If it is atom, then gram atomic mass. If it is molecule, then gram molecular mass. And this can be total number of particles upon Avogadro number. Basics समझते चलेंगे, कहीं डाउट रहेगा पूछते जाओगे. Divided by Avogadro number, which is equal to how much? This is equal to approximately 6.022 into 10 raised to 23. Is it okay? V is volume of container, P is pressure exerted by the gas on the walls of container. Any doubt up to this point? क्योंकि देखोगे आगे जाकर फ्यूचर में तो क्वेश्चन यहीं से स्टार्ट हो जाएंगे, थोड़ी सी डिटेलिंग और करेंगे, बट यू विल सी दैट कि क्वेश्चंस न्यूमेरिकल्स यहीं से अच्छे अच्छे क्वेश्चंस बनने स्टार्ट हो जाते हैं. एनी डाउट अप टू दिस पॉइंट? चलो ठीक है, फिर आगे बढ़ते हैं. मैंने बोला कि कैपिटल आर की बात करेंगे, इसके वैल्यूज की बात करेंगे, तो डेफिनेटली वी नीड टू नो कि in what unit, what is the value of capital R, because that is very important, and in future in many chapters we'll be using these values practically. So now if you see, value of R in different units has different value, but particularly we'll be practically using these two units. और उसमें भी सबसे ज्यादा मैंने देखो लिख दिया practical unit, where most of the time pressure will be in ATM, volume will be in liter, and energy will have unit of P into V. When you multiply P into V, you get the energy unit of energy. Okay, so then energy की unit is ATM liter. इसको हम लोग थर्मो में यूज करेंगे, अभी के लिए बहुत ज्यादा यूज नहीं होगा, बट P in ATM and V in liter अगर लिया है, then R का वैल्यू 0.0821, वेरी क्लोज टू 1/12, बट थोड़ा सा एरर आता है. हाँ, इसको बहुत ही क्लोज टू 1/12 बोल सकते हैं व्हेन वी हैव टेकन प्रेशर इन बार. ये कन्वर्जन भी देखेंगे, प्रेशर का कन्वर्जन वगैरह देखेंगे, सी दैट. Okay, when you are taking SI unit in which pressure is having unit of Pascal, or which is also Newton per meter square, and volume ka unit obviously will be meter cube, energy will be in joule, then R ka value is 8.314. Okay, and then energy, if it is taken in calorie, which you are going to use in one section in this chapter, and then in the next chapter thermodynamics में तो बहुत ही ज्यादा यूज करेंगे. तो if energy की unit is calorie, we can't talk about a particular unit of pressure and volume at that time, but in that unit the value of R is 1.98, which is very close to 2, तो कई बार 2 लेकर ही चलते हैं. ठीक है, any doubt? चलो अभी एक एक करके स्टार्ट करते हैं. सारे बाकी सारे टर्म्स के लिए क्या क्या कन्वर्जन रिक्वायर्ड हो सकते हैं. ऑलरेडी आई टोल्ड यू फ्यू थिंग्स, लाइक आई टोल्ड यू टेम्परेचर कैसे कन्वर्ट करते हैं, मोल्स कैसे निकालते हैं, ये सब मैंने बता दिया है ना. एनी डाउट? हाँ, वॉल्यूम में आई ऑलरेडी टोल्ड यू कि वी नीड टू बी वेरी केयरफुल व्हाइल टेकिंग द वैल्यू ऑफ आर. सो वी नीड टू बी वेरी केयरफुल अबाउट द यूनिट ऑफ प्रेशर एंड वॉल्यूम ऑलवेज, है ना. तो वॉल्यूम हो सकता है वो ml में दे रहा हो सकता है वो मीटर क्यूब में दे रहा हो सकता है डीएम क्यूब में दे रहा हो. तो ऑलवेज रिमेंबर द सम ऑफ द कन्वर्जन. व्हेन आई से मीटर क्यूब, दैट इज द एसआई यूनिट. So 1 meter cube is nothing but 10 raised to 3, that means 1000 dm cube, decimeter cube बोलते हैं. This is nothing but liter, and 1 dm cube or liter is equal to 1000 or 10 raised to 3 centimeter cube. Centimeter cube को we also call it cc, cubic centimeter. So whenever they are writing 450 cc, that means they are talking about centimeter cube, or this can also be called ml. Okay, so this is mainly the conversion of units of the volume. Okay, this was another part, and the last part is about pressure. अभी देखो क्या होता है ना, प्रेशर के लिए I'll be using the formulas, but I'll give you all the conversions required so that you'll always be comfortable while using these terms. बहुत बार होगा ऐसा यूनिट में रहेगा, लेकिन बाद में पता चलेगा एटीएम लीटर में यूज करना है, एटीएम में प्रेशर यूज करना है. So these are the conversions. I'll tell you what are these conversions. Pressure is having a unit called ATM, which is not actually the SI unit, which is a practical unit. What is 1 ATM, anyone? What is 1 ATM? Anyone?
Amount of pressure atmosphere applies in 1 unit area.
Where? If I say 0.5 ATM, then will you change your definition? Okay, obviously atmosphere is applying some pressure, but it will be applying more pressure at the sea level, less pressure in the hill area. Okay, so basically 1 ATM is that pressure which is applied by the complete atmosphere at the sea level. ठीक है, ऊपर जाएंगे तो प्रेशर कम होता है ना. So that's why what we are saying that it is, if you measure it, बाद में in future we'll understand that कि how it is measured practically or experimentally. There is something called barometer, सुना होगा है ना. So barometer is used to get the atmospheric pressure at a given any given place. At the sea level, if you apply that na, so it will be giving you this much value. इसी को पास्कल बोल लो, or we can also call it Newton per meter square. So this much is called 1 ATM. अब इसी को we can call it 1.013 बार भी बोला जाता है. Currently units are धीरे धीरे they are changing the units. They are practically using bar at many places, but अभी भी हम लोग 80s 90s में चल रहे हैं. जहां पे ये टर्म्स अभी भी चेंज नहीं हो रहा है. सो आई विल टॉक अबाउट दैट ऑल्सो. कंडीशन ऑफ टेम्परेचर एंड प्रेशर की बात करूंगा. हाँ, दिस इज ऑल्सो इक्वल टू, सी, this much pressure can be applied by any liquid also, and if you take the liquid as mercury, it will be applied by only a 76 centimeter Hg column, and that's why 1 atm is also called 76 centimeter Hg, and 76 centimeter Hg is nothing but 760 mmHg. And there was a scientist whose name was Torricelli, जिनके नाम पे इसको 670 टॉर भी कहा जाता है. एनी डाउट? ये सब आगे हम लोग कैलकुलेट करके देखेंगे. We'll be having the calculation by which we'll be exactly getting ki why I'm saying 1 atm equals 76 centimeter Hg. Right now I'm just giving you the conversion units. Okay, to understand that कि हाँ ठीक है ये conversion unit. In future we are going to exactly calculate it. ये 76 centimeter कहाँ से आया, that we are going to calculate. Okay, वैसे वाटर के लिए भी करेंगे. एंड वाटर के लिए विल फाइंड दैट कि whatever pressure atmosphere is applying ना, to apply that much pressure you need a column of water which will be having height 10.3 meter approximately. Mercury is highly dense liquid. How much dense? 1 liter के बॉटल में पानी कितना किलो आता है? How much kg water will be coming approximately in 1 liter water?
1 kg.
1 kg. If you take that same 1 kg 1 liter bottle na, it will be having approximately 13.6 kg of mercury. ओके, अंडरस्टैंड दैट कि एक बॉटल भरा हुआ है, वो पानी से भरा हुआ है, अपन ऐसे ही उठा के गड़क लेते हैं. भले तो मरकरी गटकना मत, इट इज पॉइजनस. बट इफ यू आर हैविंग 1 liter बॉटल वाटर का ना, मतलब वाटर नहीं है, अगर उसमें मर्क्यूरी रख दिया ना, इट विल बी 13.6 kg, which is highly dense, and that's why only a 76 centimeter Hg column was able to apply that much, was able to create that much difference of pressure, which is generated by the whole atmosphere, or which is generated by 10.3 meter of water column. Okay, ये सब आगे हम अपना point of discussion होने वाला है. These will be the sections we are going to discuss. But if you see within that conversion, if you see this much bar is this much Pascal. So we can say na कि 1 bar is simply 10⁵ Pascal. Okay. Any doubt in the conversions? एनर्जी का एक बेसिक पॉइंट तो ऑलरेडी समझ में आता होगा दैट 1 joule is one calorie is approximately, we are not going to use it currently, but in future we are going to use that, and that's why I'm giving you that unit also. 1 calorie is approximately 4.184, जैसा 4.2 भी बोल देते हैं approximately. We take that value as approximately 4.2 also. And if you have energy की unit already मैंने बताया, you can have atm liter also. So 1 atm liter, which is also the unit of energy, is approximately equal to 101.3 I'll say joule, and which is very close to 24.2 calorie. And 1 calorie is equal to approximately 4.2 joule. 1 kilocalorie will have 4200 joule, so that will be 4.2 kilojoule. Is it okay? Any doubt? चलो, तो ये सारे कन्वर्जन यूनिट्स थे. नाउ एक और इंपॉर्टेंट पार्ट जो कि थोड़ा बहुत मोल में तो यूज हो ही गया होगा, मोलर वॉल्यूम एट एनटीपी, एसटीपी, एसएटीपी, आरटीपी, ये सब टर्म्स आते हैं जो कि आगे भी बहुत बार आएंगे. एंड वी नीड टू नो अबाउट दोज टर्म्स कि व्हाट आर दीज टर्म्स एंड व्हाट वी आर सपोज टू डू विद दीज टर्म्स. ठीक है, तो नाउ व्हेनेवर दे आर मेंशनिंग यूनिट टर्म्स लाइक दिस ना, एसटीपी क्या है, एनटीपी क्या है, why they are using, and what we need to understand from those units, that we'll understand. And उसके बाद फिर आगे का discussion start होगा, which is the first term, and that is called molar volume. उसकी बात करेंगे हम लोग. But right now, if they are writing somewhere a gas at NTP, so the full form is normal temperature and pressure, where temperature is 0°C. But I told you earlier also, whenever we are going to take temperature in any formula, we'll be taking that in Kelvin. So we need to write 273. Don't write 0 degree C. We can write 0 if I am taking the difference in the temperature, because difference in temperature is same in degree C and Kelvin. Okay. Pressure has to be 1 atm, or we know that in SI unit it is this much Pascal. When I say SATP ना, ये SATP और STP की कहानी थोड़ी इंटरेस्टिंग है. क्या हुआ ना 1980s के लगभग में इट वाज डिसाइडेड दैट पहले एसटीपी को 1 एटीएम बोला जाता था. देखो यहाँ मैंने थोड़ा चेंज किया है ना. तो 1980s के टाइम पे इट वाज डिसाइडेड दैट कि व्हेनेवर दे आर सेइंग स्टैंडर्ड कंडीशन, so we'll be taking 1 bar as a pressure, because 1 bar is having very simple conversion with the Pascal. It is simply 10 raised to 5 Pascal. ठीक है. ये डिसाइड कर लिया गया है 1980s के टाइम पे ही. अब हो गए 40-45 साल, बट अभी भी people are stuck to that 1 atm pressure, and that's why most of the book, including some previous year question also, they have written stp but they have taken pressure equal to 1 atm. And that's why देखो अभी भी मैंने लिख दिया, एक बहुत ही इंपॉर्टेंट नोट लिखा है. तो मोस्ट ऑफ द बुक्स में भी देखोगे ना, दे आर कंफ्यूज, स्टिल कंफ्यूज. कहीं पर एसटीपी को एसटीपी की तरह, एक्चुअल एसटीपी की तरह लेंगे, दैट मींस दे विल बी टेकिंग प्रेशर इक्वल्स 1 बार. कई बार वो एसएटीपी या एनटीपी की तरह ले लेते हैं, जहां देखो प्रेशर को मैंने 1 एटीएम यहां भी लिखा है और ये भी सेम एज एनटीपी. So that's one point we have to check very carefully, very smartly, that whatever is given in the question ना, like अगर कुछ नहीं दिया हुआ है, कोई आइडिया नहीं लग रहा, तो विल बी टेकिंग एसटीपी का मतलब प्रेशर इज 1 बार. बट इफ यू चेक, आगे जाकर हम लोग मोलर वॉल्यूम की बात करेंगे. मोलर वॉल्यूम एट एनटीपी जो कैलकुलेट करते हैं ना, या एसएटीपी इज सेम. सो दैट वी कैलकुलेट एज 22.4 लीटर, है ना. ये सुना है नंबर 22.4 लीटर. मोल में आया होगा मोस्टली, है ना. मोलर वॉल्यूम एट एनटीपी की बात होती है. इफ यू हैव
सर
नॉट
अभी
लिसन.
22.7 हो गया है ना?
हाँ, तो वही मैं बोल रहा हूँ कि एसटीपी अगर अभी का लोगे, एक्चुअल डेफिनेशन से लोगे, तो दैट विल बी कमिंग 22.7. बट इफ यू स्टार्ट सॉल्विंग एनी मॉड्यूल और एनी असाइनमेंट ना, इंक्लूडिंग सम प्रीवियस क्वेश्चन, एसटीपी लिखकर दे आर स्टिल टेकिंग 1 एटीएम प्रेशर, एंड दैट्स व्हाई यू हैव टू यूज 22.4 लीटर टू गेट द आंसर. ठीक है. तो हिस्टोरिकली मैंने प्रीवियस ईयर के क्वेश्चंस वगैरह चेक करने स्टार्ट किए. कई बार ऐसा दिखा कि व्हेन दे आर राइटिंग एसटीपी, दे आर मीनिंग इट लाइक एसएटीपी और एनटीपी स्टिल, क्योंकि पुराने वर्जन कॉपी पेस्ट जैसे होते हैं, बहुत सारे लोग उस फेज से बाहर ही नहीं आ पाए. ठीक है. तो वी नीड टू प्ले स्मार्ट. मान लो इफ आई एम गेटिंग अ नंबर लाइक वॉल्यूम के लिए नंबर इज 2.24, 5.6, दैट मींस दे आर टॉकिंग अबाउट 22 पॉइंट, क्योंकि वहीं से वो कैंसिल आउट होगा. But if I start getting 2.27, 22.7, 11.35, 2.5, 4.54, तो ये सब हिंट दे रहा है कि यूज दैट 22.7 वाला. इज इट ओके? क्लियर है? आरटीपी का मतलब रूम टेम्परेचर एंड प्रेशर होता है. इट डजेंट मीन कि तुम अपने रूम का टेम्परेचर चेक करो. यू हैव टू टेक 25 डिग्री सी, गर्मी हो या सर्दी हो. When they are mentioning room temperature and pressure or RTP, we have to take temperature equals 25 degrees C, which is nothing but 298 Kelvin. Is it okay about these conditions? चलो, very good. Now, अभी जो मैंने बात की मोलर वॉल्यूम ऑफ आइडियल गैस, उसको V सबस्क्रिप्ट M से दिखाते हैं. इट इंडिकेट्स मोलर वॉल्यूम. ठीक है. सो नाउ वी हैव गॉट PV इक्वल्स nRT. मोलर वॉल्यूम का है, वॉल्यूम ऑक्यूपाइड पर मोल ऑफ गैस, है ना. सो व्हेन आई से मोलर वॉल्यूम ऑफ गैस, इट मींस वॉल्यूम ऑक्यूपाइड per mole of gas. Total volume occupied is V. Then per mole of gas, volume occupied will be V upon N, which is nothing but RT upon P. That's why we'll say molar volume is nothing but RT upon P, है ना. Is it okay? Now, ऊपर देखो मैंने स्पेशल कंडीशंस लिखे हैं टी एंड पी के. लाइक इफ आई से एट एनटीपी, द मोमेंट आई से एट एनटीपी, टी एंड पी आर फिक्स्ड ना. And when the T and P values are fixed, RT upon P will become fixed now, because R was already constant. And that's why molar volume ka value for ideal gas under a given temperature and pressure becomes a fixed value. Is it okay? So we'll write a note here. At a given temperature and pressure, molar volume of any ideal gas, irrespective of its identity, because Vm का वैल्यू ही आया RT upon P, कोई दूसरा टर्म है ही नहीं. It doesn't matter we are talking about SO2 gas or O2 gas or helium gas or methane gas, because in bracket if you see we have got RT upon P. That has nothing to do with the identity of the gas or the molar mass of the gas, है ना? And that's why we are saying that volume of any ideal gas, but we should assume the ideality. Any ideal gas, irrespective of its identity, or molar mass, has a fixed value. Okay. So basically, in all these cases, we have to use RT upon P to get the molar mass, and उसी से एक formula आ रहा है. If we have got a ready-made value of molar volume or Vm, ना, so that much into N will give you the total volume, है ना? Because Vm is V upon N, so V will be Vm into N, है ना? And that's why if we have got the value, मान लो रटा रटा value अपने पास already है, then we'll say the total volume will be total moles into molar volume at the given condition of temperature and pressure. Now already मैंने अच्छा यहाँ पे एक mistake हो गया. This is RT upon P, not V. So now already we know that कि RT upon P का value कितना है, because we have got condition NTP or STP. If you see at that value we'll be putting, जैसे मान लो किसी ने बोला molar volume at NTP, and if I want to express it in liter, so that we have to write RT upon P. Now tell me what should be the value of R if I'm talking about molar volume in liter. What should be taken as the value of R? Anyone? अभी just बहुत सारे values बताए थे ना?
0.0821.
Very good. So when I'm talking taking pressure in ATM and volume in liter, देखो यहाँ जब तक याद ना हो जाए रेफर करते रहोगे, रिवीजन करते रहोगे. Already I have written here, देखो practical unit. If P is in ATM and V in liter, then we have to take 0.0821 as the value of R, है ना? तो जब तक ये वैल्यू याद ना रह जाए, इसको रिवाइज करते रहोगे, क्योंकि ये पीछा नहीं छोड़ने वाला है. नॉट इन केमिस्ट्री, नॉट इन फिजिक्स, एंड इन मेनी चैप्टर्स. Okay, so that's why what we have to take, we'll be taking 0.0821 into how much, bolo? How much should we take? Anyone? Temperature की जगह क्या लिखूं? For NTP. NTP का मतलब it was having temperature equal to 0 degrees.
298.
नहीं. NTP or STP temperature is
273.
Okay, I'll write that. T is 0 degrees C, that means 273 Kelvin. P is 180. And that's why we'll be writing here 273. We'll not write 0 obviously, क्योंकि Kelvin में लेना है. And then नीचे तो 1 लेंगे, और जैसे मैंने pressure 1 लिया, that means I'm taking that in ATM and I'm trying to calculate volume in liter, and that's why 0.0821 we have taken, and that's why if you calculate it now, we'll be getting approximately, not exactly, but approximately 22.4 liter. Is it okay? Similarly, if I have to do this calculation at RTP, तो RTP पे we have got T equals how much? याद है क्या? Room temperature
298. Okay, 298.
25 degrees C, which is in Kelvin 298 Kelvin, and pressure was still 1 atm. And that's why if I have to calculate molar volume, I'll be writing 0.0821 into 298 upon 1. If you calculate it, na, approximately you'll be getting 24.46. और वैसे ही देखो यहाँ मैंने इंडिकेट कर दिया, तो वी नीड टू बी वेरी केयरफुल. एसटीपी का मतलब कहीं वो अभी भी एनटीपी एसटीपी की तो बात नहीं कर रहे हैं, बट इफ आई टॉक अबाउट एट एसटीपी एक्चुअल, एंड दैट्स व्हाई आई एम मेंशनिंग इट टाइम एंड अगेन, बिकॉज आई एम टेलिंग यू कि जब भी तुम अपना असाइनमेंट मॉड्यूल सॉल्व करने जाओगे, कुछ क्वेश्चन ऐसे मिल जाएंगे जहां पर देल बी मीनिंग एसटीपी का मतलब एनटीपी और एसएटीपी. ठीक है, So we need to be careful about that. Now we have got temperature का value is still 0 degree C, which is 273 Kelvin, and pressure here is 1 bar. अब जब प्रेशर बार में लेते हैं तो क्या वैल्यू होता था, अगर वो याद ना हो तो वी कैन टेक दैट कि ये 1/1.013 ATM होता था, है ना। तो कैसे भी काम कर सकते हो, ऑलरेडी मैंने बता दिया कि इट विल बिकम 0.0832 जैसा हो जाता है अप्रोक्सीमेटली। सो नाउ वो भी यूज कर सकते हैं। सो वीएम इफ आई हैव टू कैलकुलेट आई विल बी राइटिंग 0 पॉइंट, या तो ऐसा लिख लो अगर याद है वैल्यू तो, then we'll be writing this much upon 1, और if you don't remember that value, एक ही वैल्यू याद रखना है तो ये याद रखा, यहाँ 273 लिखा, बट यहाँ तो एटीएम में लिखना होगा, so that's why we'll be writing 1/1.013 because that is in ATM, है ना। So now this much will be approximately giving you 22.7 liter. Is it okay? If I say calculate molar volume of an ideal gas at 1 ATM and 27 degree C in liter, बताओ जरा कितना आएगा। It is an easier calculation, but this is also a condition which is given to you in many questions. इसका कोई नाम नहीं है इस कंडीशन का, टेम्परेचर एंड प्रेशर का, but this is the condition which is given to you because it is easier calculation. Tell me the value.
$24.63 liters.
Very good. बाकी किसी का आया क्या? See, again, I'm telling you, if one person is giving answer, that doesn't mean कि you don't have to ask the question कि सर क्या सोचेंगे, सर कुछ नहीं सोचेंगे, सर यहाँ सिखाने आए हैं। So you need to be very frank with me. If you have identified your weakness, just express it. Don't think about any other person. ठीक है, अगर डाउट आ गया तो पूछने का है, that's your right also and that's your responsibility also. Okay, हाँ, विवान का भी राइट आंसर आ गया है। Okay, let's see that.
24.63 है।
Yes, 24.63. Okay, very good. So we are getting again RT upon P, है ना, and RT upon P में if we are using pressure in ATM and temperature in degree, temperature तो Kelvin में use करते हैं, so we take and volume we are trying to calculate in liter, तो 0.0821 लेंगे, we'll be taking 0.0821, sorry, into, that is sleeping, yeah, into temperature is 27 degrees is 300 Kelvin, है ना, and that much divided by 1. And that will give you, it will be coming in liter, and that will be 24.63 liter. Okay. Now, somehow, if I know the molar volume, to calculate the volume, we can multiply the molar volume with the mole, na? Then we'll be getting the total volume because Vm was nothing but V by N. वहीं से तो start किया था, है ना? So if I'm trying to get total volume at a given temperature and pressure for any ideal gas, I'll be taking this thing, है ना? चलो जरा ये क्वेश्चन सॉल्व करके बताओ फटाफट। चार को, there are 4 questions. I'll be giving you atomic masses. Sulfur is 32, oxygen is 16, carbon is 12, H is 1.
सर पहले वाले का 5.6।
ओके, इनका आंसर आ जा रहा है, मूव कर जाओ। Somehow, if we know the molar volume and we know the moles, then we'll be getting the volume, है ना? That's the formula. Total volume is total moles into molar volume, है ना? That's the formula. Molar volume at NTP already we have decided above, है ना? 22.4 liter was the molar volume, है ना? So we have to use that only. So in first question, if I'm trying to get the solution of the first question, we need to get the moles. So moles of SO2, if you want to know, that will be total mass upon molar mass. Molar mass is 80, है ना? SO3 का. And that's why it will be 1 by 4. And that's why if you want to know volume, it is moles upon molar volume. And that will become 1 by 4 into 22.4 liter. Because at NTP, molar volume is 22.4 liter. है ना? And that's why it will be simply 5.6 liter. So the only job we have got in this question is to get the number of moles. If I'm trying to get the moles of O2, now we have got total number of molecules. How to get the moles? Anyone?
Sir, 3.011 upon into 10 raised to 22 upon Avogadro.
Avogadro number, है ना? Total number of particles upon Avogadro number, है ना? So that's why we'll be writing 3.011 into 10 raised to 22 upon 6.022 into 10 raised to 23. Now if you see, it is coming 1 by 20. Okay, and that's why if I am trying to get the total volume at NTP, it will be again moles into molar volume. Moles is 1 by 20 and molar volume is 22.4 liter. And that's why this will become 1.12 liter. Is it okay?
सर थर्ड वाले का 33.6 लीटर और फोर्थ वाले का
moles
पॉसिबल
already
नहीं,
पता है. Possible नहीं means there will be
मतलब
some.
PV इक्वल्स टू एनआरटी एप्लीकेबल नहीं रहेगा.
Okay, very good. So that was a trick question actually कि once we have learned something ना, ऐसा जरूरी नहीं कि हर जगह अप्लाई करने का. चलो थर्ड वाले कर लेते. It is simply N into Vm and moles is given directly 1.5 into 22.4, and if you calculate it, you'll be getting 33.6 liter. You know? Last wala question is about liquid water. You can't apply ideal gas equation to a liquid, है ना? And that's the message we have got from this question, that if it is a liquid, we have to use somehow density, and if density is not given anything about liquid water, we have to take 1 gram per ml. यहाँ तो मैंने दे दिया है. कभी कभी they'll write specific gravity is this much. Specific gravity numerically same as density in gram per ml. Okay, so now if it has given me 3.6 gram liquid water, I can calculate moles. Moles जाने की जरूरत ही नहीं है. Mass is given. We know that na density is mass upon volume. So volume will be mass upon density. So that we have to use here. And while using that, see, mass is 3.6 gram and density is 1 gram per ml. So that's why it becomes 3.6 ml. That will be the answer. अगर लीटर में पूछता तो we'll be writing this much into 10 raised to minus 3 liter. Okay. But if you calculate with the ideal gas equation, can you tell me how much will be that value? If I say H2O gas hota 3.6 gram, how much will be the value? Assuming ideality, obviously.
सर 4.48 आता है.
Okay, let's see. And that much liter आएगा है ना?
हाँ सर.
अभी तो देखो, अभी तो 3.6 into 10⁻³ लीटर आया है for H2O gas, assuming ideality. If mass is
हाँ सर 4.4.
3.6 gram, then moles will be 3.6 upon 18, which is 0.2. And that's why B will be 0.2 into 22.4 liter. And that is coming 4.48 liter. यहाँ आया 3.6 ml, है ना? And that's the difference I was talking about when I was talking about the volume of state will be much, much higher in the gas than the liquid or the solid. This was the meaning because it is almost more than 1,000 times, है ना? It is more than 1,000 times we are getting volume of the gas in comparison to the volume of liquid. Is it okay? So it was not the question here, but just to have the comparison, just to give you the perspective ki किस range में we are getting the change in the volume when some substance is going from liquid to gaseous state. What is the range of change in volume? And this is the range. It is almost more than 1,000 times. है ना? Is it okay? So I'll be giving you some of the question from PV equals nRT. You have to use that. एक दो क्वेश्चन करके देखते हैं. Any doubt up to this point? Any doubt? No? Good. Then it's going good. But again, I am telling you, अभी तक भी अगर हिचक रहे थे तो do not hesitate in asking any doubt. Do not judge yourself कि ऐसा doubt कैसे पूछेंगे. If you have doubt, ask it. Otherwise, solve it. Now, if you need atomic masses, I'll give you. Ammonia, you know? What is ammonia? Anyone? NH3 है ना?
NH3.
तो नाइट्रोजन के लिए 14 है, हाइड्रोजन के लिए 1 है, O दिख रहा है तो O के लिए 16 है. So ammonia, for those who are not knowing this name, it is NH3 gas.
Sir 8.21 ATM.
Okay, I'll wait for other people also. Have you got a difficult calculation or easier calculation?
Sir easy है.
Okay, okay. That's the hint for other people if they are getting difficult calculation. One thing I have learned while solving the question of physics, particularly Irodov की जो book आती है, that you should always carry the calculation till end, and then if it is needed, then do the calculation. Okay, if you follow that part ना, कई बार होगा ना, बहुत सारी चीजें अपने आप cancel out हो जाएंगी. It will give you an easier calculation. Don't do the calculation at every step. मतलब कुछ मिल गया calculation इसलिए कर देना है. Don't do that. Carry the calculation. End में जाके देखेंगे. हाँ, बहुत simple calculation रहे तो immediately you can do it. But if you think that कि थोड़ा difficult जा रहा है, carry the calculation. It is possible. कई बार number set किया जाता है ऐसा ही. If you go to the final calculation, final stage of calculation, many things will be cancelled out, or it will become easier. Okay, let's see. Anyone else have got who have got the answer? देखो, we have got PV equals nRT, वही use करना है ना. We are knowing that if I am assuming ideal behavior, we have got this only one equation, PV equals nRT. आज का पूरा खेल इसी पे रहेगा, and you will see that many variation of this same equation. Now, if I am talking about container A, so I can write now P of A will be moles in the A into R into temperature of A upon volume of A. Simple. PV equals nRT, यही तो यूज किया. Now, while doing that, if you see अमोनिया गैस के लिए it is 8.5 upon 17 हो जाएगा n का वैल्यू, टोटल मास अपॉन मोलर मास, इनटू r का वैल्यू आई एम कैरिंग राइट नाउ. लिख के भी कोई फायदा नहीं है क्योंकि अभी मैं कैलकुलेशन करने वाला हूं. इनटू t का वैल्यू if you see 27 डिग्री C है, that is nothing but 300 Kelvin. Kelvin I am not writing it right. Upon pressure I am taking in ATM, volume I am taking in liter, and that is 2.5. Now, if you simplify this much, na, so इतने को simplify कर सकते हैं. 8.5 by 17 is 1 by 2, and 2 into 2.5 is 5. So this becomes 60 R. Is it okay? And then, if you calculate PV, we can write NB into RTB upon VB, है ना? And that will become, this is 64 by 32 into R into the temperature is now 400 Kelvin and the volume is 5 liter. If you calculate it, 2 by 5 आ रहा है तो 160 आ रहा है. And because we have taken pressure in ATM, we are trying to get pressure in ATM and we have used volume in liter, we have to take R equals 0.0821. And that's why पहली बात तो ये पता चला PV is greater than PA. And then if they are asking you difference in pressure, it will be PV minus PA. And that will be 160 R minus 60 R, which is equal to 100 R. And because we have used volume in liter and we are trying to get the pressure in ATM, I'll be using 0.0821. And that's, now it is in ATM. And if you calculate it, now it is very simple calculation. And this will be the answer. Any doubt? If you don't have any doubt, start solving this question. जिनको भी doubt है, while noting it down, always ask your doubts, always resolve your queries. मतलब ये कसम खा लेनी है कि doubts छोड़ के तो नहीं जाना है क्लास. सर ने promise किया है that he will be giving reply to all your doubts, तो sir will keep his promise. ठीक है? तो you have to also ensure that कि if I am getting doubt, I have to ask it. तो पूरा मैं नीचे करता हूँ.
20.
Okay. Anyone else having any answer? Again, we have got PV equals nRT. एक ही लाइन की थ्योरी है. इसी के different forms देखेंगे obviously, but right now in today's lecture, this is the only truth for the lecture. PV equals nRT.
सर मेरे को 40 आ रहा है.
Okay, so that means one of you are must be wrong. I don't know कि both of you are wrong or not, but one to definitely, one of you is definitely wrong. Anyone else having any answer? Okay, Vivan has also got same answer. One of the answer is same. Anyone else? Well, I'll
It is
just
40, sir.
40 again. Okay, तीन लोगों का 40 आया, one का 20 आया. Not a problem. So see, even if you are getting wrong answer, always report it, because then I'll ask you the point of mistake, and when you start discussing it, na, it is a success. Believe me. When you get that stage where you can frankly discuss your mistakes, na, it is your success, because when you start discussing your mistake, it will always be with you that I had done some mistake which I discussed, so you'll not repeat it. If you don't discuss your mistake, so there is a chance that you will repeat your mistake. So whenever you are getting some mistake, ना, मेरे क्लास में तुम्हारे सीनियर बच्चों में कल्चर है, क्वेश्चन के बाद सॉल्व करने के बाद दे ऑलवेज से, सर मैंने ये मिस्टेक किया, सर मैंने ये मिस्टेक किया. मतलब इट इज अ डिफरेंट क्लास टोटली. सॉल्यूशन तो ठीक है, मैं बता देता हूँ बाद में, बट उसके बाद दे स्टार्ट डिस्कसिंग देयर मिस्टेक कि सर मैंने यहाँ पे किया, और अदरवाइज आई आस्क देम कि तुमने कहाँ मिस्टेक किया, तुमने कहाँ मिस्टेक किया. व्हाई आई एम डिस्कसिंग दिस मिस्टेक, सो दैट यू डोंट रिपीट दिस थिंग्स. ठीक है. सो नाउ इफ यू सी द सिंपल थिंग इज, इट इज सेइंग दैट कि क्या इक्वेट करने का है, तो प्रेशर. ओके, उदयन हैज गॉट द सेम आंसर. ओके, लेट्स सी. So it is saying कि we need same pressure. That means we are saying P of H2 जितना आ रहा है ना, वो same आना चाहिए that of P of O2, which means, and again we'll be applying that PV equals nRT. So we'll write P n of H2 into R into T of H2 upon V of H2. I am writing that because I told you कि if you keep carrying the calculation, sometimes many things or few things will be cancelled out. And that's the purpose of writing all these things. देखो R तो पहले ही कट गया, तो बहुत सारे टर्म्स कट जाएंगे, तो यू डोंट हैव टू डू मेनी कैलकुलेशंस. नाउ व्हाइल डूइंग दैट, इफ आई कीप n of H2, देखो R is cancelled, so that will be equal to moles of O2, that I'll write now because we have got the number of molecules. So number of molecules upon Avogadro number will give you the moles of molecules. That much into R gets cancelled. I'll be writing T of O2, which is 546. यहाँ अगर 273 लिख दिया तो mistake हो गया, because this was not in Kelvin, this was in degree C. So this is equal to 546 Kelvin. Is it okay? Mistake पता चल जाए तो बता देना, इनका भी मिक्स हुआ है. 0 degree C is 273 Kelvin. So this is temperature का ratio into V of H2, which is 3, and V of O2 is 1.5. And that says, ये वाला तो देखो 10/2, that means 5 आ गया, ये वाला देखो 2 आ गया, और ये वाला भी 2 आ गया. That means we have got this as 20, but it is not asking you moles, it is asking you mass, and that's why mass of H2 will be moles of H2 into molar mass. And that's why it will be 40 gram. What are the mistake? क्योंकि 20 आने के बहुत सारे chances थे इसमें. What are the mistake? 20 जिसका आया था.
सर मैंने मोल से रिपोर्ट किया.
ओके, सो ये एक लर्निंग है. देखो व्हाई आई एम डिस्कसिंग ऑल दीज थिंग्स ना, बिकॉज इसको बोलता हूं मैं, वहां कश्ती वहां थी डूबी जहां पानी कम था. यू डिजर्व दिस मार्क्स, बट यू हैव गॉट द नेगेटिव मार्क्स. सो वी नीड टू ऑलवेज रिमाइंड आवरसेल्फ, इट इफ इट इज अ प्रॉब्लम विद एनीवन, ऑलवेज रिमाइंड योरसेल्फ कि चेक करना है व्हाट आई एम रिपोर्टिंग, व्हाट इज बीइंग आस्क्ड. इट विल टेक जस्ट 5 सेकंड, ठीक है, बट इट इज वर्थ फॉर एवरी क्वेश्चन, बिलीव मी. क्योंकि बहुत बच्चे होते हैं, सर करेक्ट पूछा, इनकरेक्ट पूछा तो मैंने करेक्ट टिक कर दिया. and it is a frequent mistake. So always you, while reporting the answer, always take, it will just take 5 seconds to verify it, what I am reporting, what is being asked. तो मैं रिपोर्ट क्या कर रहा हूँ, मोल्स रिपोर्ट कर रहा हूँ. अच्छा, पूछा क्या है, मास पूछा है, याद आ जाएगा कि मिस्टेक कर दिया ना. ओके, वन मोर क्वेश्चन. जेई का पुराना क्वेश्चन है, काफी पुराना, इनफैक्ट 25 years पुराना क्वेश्चन है, बट पीवी इक्वल्स एनआरटी से क्वेश्चन कम बनते हैं. तो दिस वाज वन ऑफ द गुड क्वेश्चन फ्रॉम पीवी इक्वल्स एनआरटी. ट्राई करो जरा.
Sir, 123.15 grams.
Okay, I don't remember actually the answer, but
23.15.
okay, okay. Anyone else having any answer? सेम है, डिफरेंट है, बोलने का, रिपोर्ट करने का. अपने क्लास में एकदम डेमोक्रेसी है. What does it mean? Empty container was 50 gram, and when filled with a liquid, it is 148 gram. What mathematical implication you can get from here?
Sir, mass of liquid is 98.
98 ग्राम है ना, तभी तो ये 50 का 148 हुआ. दैट मीन्स मास ऑफ लिक्विड is 148 minus 50 gram, which is 98 gram, and they have given you the density. Density is, अभी जस्ट हम लोगों ने यूज भी किया था, मास अपॉन डेंसिटी इक्वल्स वॉल्यूम, है ना. तो डेंसिटी इज 0.98 ग्राम पर ml. तो वी कैन कैलकुलेट द वॉल्यूम ऑफ द लिक्विड ना. उससे फायदा क्या हुआ? अंशुल हैज गॉट द सेम आंसर. सब लोगों का लगभग सेम ही आ रहा है, सेम ही आ रहा है. इनफैक्ट वॉल्यूम ऑफ लिक्विड विल बिकम 98 अपॉन 0.98 ml, which is 100 ml. और ये वॉल्यूम कुछ नहीं है, ये वॉल्यूम ऑफ द कंटेनर है ना. तो दैट्स व्हाई कंक्लूजन, एंड दिस वाज द पर्पस ऑफ डेटा, वॉल्यूम ऑफ कंटेनर is equal to 100 ml, or we can say it was 0.1 liter. That was the use of the first data. Now it says when you are filling it with gas now, if you are filling it with gas, if this is gas, then it has got the mass 50.5 gram. इसका मतलब है mass of gas here was 0.5 gram. Now it says that the pressure is 760 mmHg, which was nothing but 1 atm, and temperature given is 300 Kelvin. Now just apply PV equals nRT, and volume we have got already 0.1 liter. So we can write PV equals nRT for this gas, and when I am applying that, 1 into 0.1, because we have taken pressure in atm and volume in liter, that's why we have to take यहाँ मैं सिर्फ n लिख रहा हूँ अभी, n of the gas, into we have to take 0.0821 into, and temperature given is 300, और ये अभी जस्ट हम लोगों ने किया था कैलकुलेशन. That says n का value is coming 0.1 upon 24.63, which is 1 upon, or we can say 10 upon 2463. And now it says mass मिल गया, moles मिल गया, तो molar mass क्या होता है? So molar mass is total mass upon total moles. And that's why it will be 0.5 upon 10 upon 2463. Then it becomes the easier calculation. Huh? Now, if you see 5 into 2463 upon 100 हो गया, तो 24.63 into 5 करोगे, 123.15 will be the answer. Is it okay? Anyone having any doubt? किसी का mistake भी हुआ कुछ? Anyone having any mistake? या फिर जो नहीं सोच पा रहे थे, have you identified the point जो future में you have to take care? है ना, while learning जो सोचना थोड़ा सा ट्रिकी हो जाता है, कुछ लोग सोच पाते कुछ नहीं, कि ये लिक्विड का झमेला क्या था, ये मामला क्या था. तो the purpose of putting the liquid inside the container was to give you the idea of the volume of the container, है ना. That was the main purpose. Any doubt? So now we are entering into the next topic, which is still it is about PV equals nRT, but right now we'll be seeing the other forms of this PV equals nRT. There are three forms we'll be talking about. ये जो पहला वाला फॉर्म है वो तो सिंपली there was another scientist जिनका contribution था in the kinetic theory of gas, and the name of the scientist was Boltzmann. तो उनके लिए ये इक्वेशन बना के रखा गया. दूसरा वाला जो है, this will be used in chapter called chemical equilibrium. ये सब मैं बताऊंगा कहां से आया है. थर्मो के बाद का चैप्टर होगा. ओके, एंड इसको तो अभी ही यूज करके बहुत ज्यादा देखेंगे. इनफैक्ट पता नहीं मुझे तुम लोगों को मोल में करवाया था कि नहीं, वेपर डेंसिटी का टर्म लाने के लिए वी आर गोइंग टू यूज दिस फॉर्मूला. ठीक है, तो कैसे आया ये तीनों फॉर्म, जस्ट सी दैट वी हैव गॉट पीवी इक्वल्स एनआरटी एंड वी हैव गॉट डिफरेंट इंटरप्रिटेशन ऑफ दिस सेम थिंग. तो पहला वाला फॉर्म जो है ना, इफ यू सी, वी नो दैट moles can be written as चलो पहले केटी वाला लाना है तो ठीक है. We know that कि total number of particles upon Avogadro number can give you the moles, है ना. Is it okay? Now if you see, we have got two constants in the same equation. What are those two constants? What are the two constants? Anyone?
RNN.
RNN है ना. तो कहा कि दो कांस्टेंट अलग अलग क्या कर रहे हैं, दोनों को मिला दो. और फिर बोला ये दिस हैज बिकम अनदर कांस्टेंट, तो इट वाज कॉल्ड के टी. तो यहाँ पे अब ये जो है, दिस इज कॉल्ड this is equal to R upon Na, obviously, is equal to R upon Na, which will have value. अगर SI यूनिट में बात करते हैं हम लोग, तो SI यूनिट में देखो R का वैल्यू was 8.314, Na का वैल्यू 6.022 into 10⁻23 है. So now, and if I talk about unit के साथ, this was joule per Kelvin per mole, and this is having unit per mole, and that's why it is approximately equal to 1.38 into 10⁻⁻23 joule per Kelvin, and this constant is called Boltzmann constant. This is called, JEE ने एक बार इस पे भी क्वेश्चन पूछा हुआ है. इनफैक्ट it talked about the number of significant figure in the calculation, is called there were three scientists जिनके बारे में आगे बात करेंगे हम लोग इसी चैप्टर में. मैक्सवेल, बोल्ट्जमैन एंड क्लॉसियस, इन तीनों ने मिलके काइनेटिक थ्योरी ऑफ गैसेस दिया था. एंड क्लॉसियस वाज मोर इंटरेस्टेड इन थर्मोडायनेमिक्स, तो ही मूव्ड ऑन टू थर्मोडायनेमिक्स. बट मैक्सवेल और बोल्ट्जमैन ने दोनों ने मिलकर आगे भी काम किया, एंड जो काम उन्होंने 1850s में किया, आफ्टर 100 years 1950s में जाके इट वाज एक्सपेरिमेंटली प्रूव्ड दैट these two scientists were telling us the right thing. It took 100 years. So Boltzmann constant. And when I'm talking about this equation, so N, now this is total number of gases, particle, not moles. Capital N is total number of gaseous particles. Okay. Second is very easy. P is equal to N upon VRT. And N is moles, V is volume. मोलरिटी पढ़ा था ना हम लोगों ने. मोलरिटी नॉर्मली जब हम लोग पढ़ते हैं तो एक्वस सॉल्यूशन में पढ़ते हैं या फिर किसी सॉल्यूशन में पढ़ते हैं, एंड वी से दैट मोल्स ऑफ सॉल्यूट अपॉन वॉल्यूम ऑफ सॉल्यूशन, है ना. इफ आई एम टॉकिंग अबाउट अ गैस फेज system now, so we can say N is moles of gas and V is volume of the gaseous system, and that's why we can also call it concentration into RT, or we can also call C as molarity. C, which is equal to N upon V, is equal to molarity. Okay. This was another form. Any doubt up to this point? If you have any doubt, just ask. चलो थर्ड फॉर्म पे जाते हैं. थर्ड फॉर्म इज इंपॉर्टेंट और उसकी बेसिस पर विल बी डूइंग सम क्वेश्चंस आल्सो. We have got PV equals nRT, and now I'll be writing the another form of moles, and that was mass upon molar mass. And then now I'll rearrange it. Capital M को left में लेकर आ गया. Mass upon volume is what? What is mass upon volume?
Density.
Density, and that's why we are writing PM equals dRT, or sometimes we write PM equals rho RT, or we also write PM equals rho RT. इसकी एनालिसिस जरा करेंगे अभी डिटेल में with this formula. So now if you see, when I'm writing PM equals dRT or rho RT, D और rho के लिए जो कंडीशन आया, that is PM upon RT. तो what I'm doing, P upon RT लिख दिया एक साथ, and then into M लिख दिया. और पहले भी हम लोगों ने किया, RT by P was molar volume, है ना. That's one part. But if you see, it is having two parts, one part and second part. Now that says, if you increase the pressure, density will increase. If you increase the temperature, density will decrease. If you increase the M, density will increase. That means if you are keeping the temperature, pressure and molar mass same, then density will also be same. Hai? These are the three messages we are getting from this equation. Okay. Any doubt up to this point? क्योंकि आगे क्वेश्चन ही है.
Sir.
हाँ
PV is equal to small m by capital M RT के बाद आपने P into capital M.
I have brought capital V on the right side and capital M on the left side. इतना ही किया
ओ अच्छा अच्छा ओके ओके
है ना?
सॉरी.
Okay, anyone else having any doubt? कुछ भी है तो पूछ लोगे, घबराना नहीं है, शर्माना नहीं है, डायरेक्ट पूछना है, बिकॉज आगे इसी को यूज करने वाले हैं. चलो, इफ यू डोंट हैव डाउट तो विल स्टार्ट सॉल्विंग द क्वेश्चन. Okay, solve this one. Okay, we have got one answer. This question was just to give you the idea कि what conversion units we have to use. मतलब कौन सी unit लेकर चलना है so that we get the right answer. Because if you take the wrong unit, then you'll be totally getting the different zone of the answer. Range ही change हो जाएगा. And another purpose of this question was to give you again the idea कि density का difference with liquid and gas कितना फर्क पड़ता है. What is the difference between the density of a gas and the liquid? We know that water अगर liquid होता है तो normally its density is around 1 gram per ml है ना?
सर 0.08 है.
Okay, let's see. So we have got the directive formula. D is equal to Pm upon RT. While doing all these things, now we need to take care of the units. While taking care of the units, if you see pressure, if I'm taking 1, and if it is gram per liter, so we have to take 18 gram per mole, है ना? And that divided by 0.0821 into 300, this will give you value in gram per liter. And that is, if you remember, this is 18 upon 24.63. कई बार use कर लिया है. अगर ये 18 by 24 होता ना, then you'll be getting 3 by 4, that means 0.75 है ना? तो approximately it will be slightly below 0.75 है ना? If you get the answer na, very close to, it will be coming 0.7308 ऐसा कुछ आएगा. ठीक है?
हाँ सर मैंने वो मोलर मास H2 का लिया था. H2O का नहीं.
Okay, we need to be careful about that also, ना? Okay, so this was one part. Now, if you remember, liquid water की density जो होती है ना, that is 1 gram per ml. That means 1 liter we will have approximately 1000 gram. And that's the difference between the density of H2O liquid and the gas, है ना? So this was one of the purpose. But we can have another question based on that same PM equals DRT पे. Just solve this question. I'll give you. Solve this one.
सर बी।
सर बी।
Someone has got C also. So I'll be waiting for other people. Okay, basically when it says neon, that means it has fixed what? Capital M, है ना? Now we know that D is already मैंने इसको divide कर दिया था दो part में P upon RT into M. That means for given M, because the gas का name is fixed, for given M, D is proportional to P upon T. So you have to check in all the options किसका value P upon T का highest है if it is asking highest density. For this P upon T का value we are taking and we are taking in ATM per Kelvin. ऐसा कोई भी एक unit fix कर लो. So like for this one it will be equal to 1 in ATM because NTP is 1 ATM upon temperature it's 273. For this option we have got 2 upon 273, that is double of the first one. If you see this one, it has got 1 upon 546, that is half of the first one. So B ka to 1/4 ho gaya. And this is 2 upon 546, which is equal to 1 upon 273. And that's why the one which has got the highest value of P by T is B. Okay, and that's why it will have the highest density. What was the mistake, Udayam? What was your mistake?
सर पी बाई टी नहीं लेके टी बाई पी ले ले।
हाँ, बहुत बहुत केयरफुली देखो, जब तक याद नहीं हो जाता है ना, इफ आई एम डूइंग सम मिस्टेक डायरेक्ट लेने के चक्कर में, तो आई राइट दिस वन पीएम इक्वल्स डीआरटी, ठीक है? तो पीवी इक्वल्स एनआरटी का ही थोड़ा सा मॉडिफिकेशन ये लाइन है. इफ यू रिमेंबर दिस लाइन तो फिर मिस्टेक नहीं होगा, और फिर नेक्स्ट स्टेप में लिख लेंगे डी इज इक्वल टू पी अपॉन आरटीएम, पीएम अपॉन आरटी, है ना? पीएम मींस प्राइम मिनिस्टर, तो ऐसे भी याद हो जाता है थोड़ा कि पीएम पीएम करके वर्ड आया था पीवी की जगह. ओके, चलो वन मोर क्वेश्चन आई विल गिव यू, and it can be one or more than one correct. Solve this one.
सर मल्टीपल करेक्ट है कि सिंगल करेक्ट है?
One or more than one, मल्टीपल कभी नहीं बोलते हैं, इसे वन और मोर देन वन, दैट मीन्स हो सकता है कोई एक ही आंसर हो सकता है मल्टीपल.
सर ए बी सी.
ओके, again the formula is same, pm equals drt, so d is equal to pm upon rt. So the any option which is having identical value of p into m upon t will have the same density, na, because r is constant. Okay, so for this part, if you see n2 at ntp के लिए, if I write p into m upon t, that is पूरा कैलकुलेट करने की जरूरत नहीं है, just see the number, and that we are calculating in ATM, ग्राम पर मोल पर केल्विन, है ना? यही चारों चीज, ये तीन चीजें दिख रही है ना? तो मोलर मास इज ग्राम पर मोल, ATM is pressure, temperature is Kelvin, है ना? So this value is coming how much? तो P is given as 1 ATM, है ना? N2 है तो ये 28 है, and T is 273. So we are writing simply 28 by 273. This value will be comparing everywhere. अब देखो NTP दिया हुआ है ना, तो सिर्फ मोलर मास भी कंपेयर कर सकते थे. When we have got the identical temperature and pressure का condition, then molar mass अगर बराबर होगा तो density भी equal होगी, है ना? तो if condition of temperature and pressure is identical, just compare the molar mass. तो A option के लिए P into M upon T जो आ रहा है, that is again 1 into 28 by 273 आ रहा है. So that's why it will have same density. B option के लिए भी if you calculate this value P into M upon T, so again if you see molar mass is 28 only and condition of temperature and pressure is same. So 1 into 28 by 273. So this will also be answer. If you see the C option, if I am talking about C option, na, then if you see M is not same, but condition has also been changed. So P is still 1. M is now, if you calculate 48 plus 8, 56 we are getting. But the temperature also is 546. And if you simplify it, again we are getting 28 upon 273. So we are getting the same value. So C will also be the answer. But if you see the D option, P into M upon T is equal to P का value is 0.5 into M का value if you calculate 72 plus 12, 84 upon 273. So that is 42 by 273, which is not same as 28 by 273, and that's why this will be rejected. Is it okay? Anyone else having any doubt? Anyone having any doubt? चलो, तो दिस वाज अबाउट PM इक्वल्स DRT और डेंसिटी का सॉल्यूशन था. नाउ एक normally I teach that in mole concept itself, but यहाँ पे because we are discussing the density, so I'll be discussing that part also. I'm going to talk about vapor density. Because that इसका formula uses the term PV equals nRT और PM equals DRT. Now vapor density define कैसे किया गया है? तो it is equal to density of given gas at a given temperature and pressure upon density of H2 gas has been taken as the reference. केमिस्ट्री में बहुत आगे लोगों को रेफरेंस में जाने की, जैसे स्पेसिफिक ग्रेविटी में H2O इज द रेफरेंस. एटॉमिक मास और मॉलिक्यूलर मास में C12 के एटम्स का 1/12 which is called 1 AMU is the reference. तो वैसे ही if you see this one, if I have to calculate it ना, अभी देखो क्या होगा यहाँ पे, if I go in detail, तो density can be written as PM upon RT, है ना? तो P upon RT into M of the given gas upon P upon RT into M of H2. And that simply is because the temperature and pressure we are taking same, and that's why we have to write M of gas upon M of H2. And M of H2 कितना होता है? It is 2 only, है ना? And that's why एक रट्टा लगवा दिया जाता है that vapor density is nothing but is equal to molar mass upon 2. Is it okay? Clear है ना? So that we are going to use in future also. There is a section in which we are going to discuss this concept that vapor density is equal to molar mass by 2. Any doubt up to this point? Any doubt? Okay. चलो, तो फिर आगे बढ़ते हैं. now we'll be going to something which was actually discovered earlier, but मैंने उसको उल्टा करके रखा है. ये आइडियल गैस इक्वेशन जो है ना, इससे पहले there were some experimental gas laws which came first, and based on all those experimental gas laws, ideal gas equation was derived. But I am keeping it in a different way, because एक बार अगर PV equals nRT पता हो गया ना, तो फिर ये लॉज जानना आसान हो जाता है. जस्ट देखो ना क्या है यहाँ पे. If I write PV equals nRT, अब इसमें से R is already a constant, बाकी चार में से कोई दो कांस्टेंट कर लो तो बची हुई दो चीजों का रिलेशन आ जाएगा ना, है ना. तो लाइक इफ आई से temperature and moles are constant, तो n into r into t is constant, so p into v is constant, है ना. सिंपल सी चीज है. तो इसी पे क्या हुआ ना, ऐसे तो आइडियली यू कैन हैव 6 लॉज, लेकिन एक्सपेरिमेंटली देयर वर 4 लॉज व्हिच वर derived by keeping two of the parameters constant. Like Boyle's law was, when n and t was constant, so p into v will become constant, है ना. तो if p into v is constant, so we can say v is inversely proportional to p, or we can say p is inversely proportional to v. एक और चीज है यहाँ पे, when I'm saying p into v equals constant, we can differentiate it. And if you differentiate it with respect to, because sometimes they'll be asking you differential form also, तो डिफरेंशिएशन सीखा है ना. हाँ जी.
हाँ सर.
ओके. सो p into v का डिफरेंशिएशन करना है, इट इज मल्टीप्लीकेशन ऑफ फंक्शन का डिफरेंशिएशन करना है ना. तो fx into gx का डिफरेंशिएशन विल बी f dash x gx plus g dash x fx, है ना. ये तो होता है. तो इफ आई राइट d by dv of pv will be equal to, इधर तो जीरो हो जाएगा ना, बिकॉज कांस्टेंट का डिफरेंशिएशन इज जीरो, है ना. एंड दैट्स व्हाई विल बी राइटिंग v dp by dv is equal plus p into dv by dv, तो 1 हो गया, and that is equal to 0, which means we can write p dv by dp by dv plus p is equal to 0, and we can also write dp by dv is equal to minus p by. This is one of the conclusion from Boyle's law at this condition: temperature constant, moles constant. Is it okay? Any doubt? Any doubt?
No sir.
So, similarly, in the same manner, we can have pressure and moles constant. If pressure and moles are constant, that law is called Charles' law. And then, again, if I write PV equals nRT, it becomes obvious that if pressure and moles is constant, V is directly proportional to T, na? And that's why we are saying if V is directly proportional to T, then V by T will become constant. We can write V upon T is equal to constant. Now, if V by T is constant, which means V is equal to, we know that that constant is nothing but nR by P. Na? So if you differentiate it with respect to T, so dV by dt becomes nR by P, which is a constant. Because n and P both are constant. Is it okay? We'll say dV by dt will be constant here. Any doubt? There is a third law which is called Gay-Lussac's law. In that, V and N were kept constant. तो इट लाइक लास्ट टाइम P कांस्टेंट किया था, इस बार V कांस्टेंट किया, तो लास्ट टाइम जो V में रिलेशन आया था इस बार P में आएगा, बिकॉज P एंड V आर एक्सचेंजेबल, है ना. P एंड V आर हैविंग सिमिलर रिलेशन. P की जगह V की जगह P कर दो, रिलेशन इज नॉट डिस्टर्ब्ड, है ना. PV equals nRT बोलूं या VP equals nRT बोलूं, दैट इज सेम, है ना. एंड दैट्स व्हाई इफ आई एम कीपिंग वॉल्यूम एंड मोल्स कांस्टेंट, वॉल्यूम और मोल्स कांस्टेंट हो गया, तो P इज डायरेक्टली प्रोपोर्शनल टू T. If P is directly proportional to T, then P by T is equal to constant. So P1 by T1 is equal to P2 by T2. तो यहाँ हम लोग लिख सकते हैं P by T is equal to constant. एंड जैसा ऊपर V by T constant किया था, वहां से रिजल्ट क्या आया था? तो द रिजल्ट वाज dP by dt is equal to constant, and that constant is nothing but nr by V this time, and because n and V is constant, that we have already learned here. Is it okay? अब इतना जब हुआ ना, तो देयर वाज अ टर्म जिसको बहुत गुस्सा आ गया, एंड दैट वाज मोल. हर बार मोल्स को ही क्यों कांस्टेंट रखने का है? देखो बॉयल ने भी मोल्स के साथ टेम्परेचर कांस्टेंट किया, चार्ल्स ने मोल्स के साथ प्रेशर कांस्टेंट किया, गेलुजाक ने मोल्स के साथ वॉल्यूम कांस्टेंट किया. नो एवोगाड्रो आए और उन्होंने बोला चलो मैं मोल्स को वेरी करवा देता हूँ, इस बार टेम्परेचर प्रेशर को कांस्टेंट करवा देता हूँ. एंड व्हेन ही केप्ट टेम्परेचर एंड प्रेशर कांस्टेंट, देन V was coming proportional to moles because PV equals nRT. If you see again, अच्छा ये सारे एक्सपेरिमेंटल गैस लॉ जिनका कोई प्रूफ नहीं है, तो उन्होंने एक्सपेरिमेंट कर करके निकाले, उसके बाद आइडियल गैस इक्वेशन है. बट वी आर चालाक पीपल, हम लोगों के पास ऑलरेडी आइडियल गैस इक्वेशन है, तो उसके स्पेशल केस की तरफ वी आर जस्ट लर्निंग दिस लॉज. ऐसा नहीं कि आइडियल गैस इक्वेशन से ये आया है, वी आर लर्निंग इट इन अ वे दैट विल मेक इट इजियर, है ना. तो पीवी इक्वल्स एनआरटी में इफ आई एम कीपिंग पी एंड आरटी एंड कांस्टेंट, देन वी इज प्रोपोर्शनल टू एन, है ना. इफ v is proportional to n, then v by n will be constant, so dv by dn will be constant, है ना. We are saying v by n is constant, and we know that that constant is nothing but if you calculate v by n, so that will be rt by p. That is nothing but molar volume, है ना. So this is nothing but molar volume is constant if you are keeping temperature and pressure constant. इसको तो start में ही पढ़ा था. This is nothing but molar volume. तो इसलिए उन्होंने बोला था किसी भी गैस का मोलर वॉल्यूम विल रिमेन कांस्टेंट एट अ गिवन टेम्परेचर एंड प्रेशर, और वॉल्यूम विल बी प्रोपोर्शनल टू मोल्स एट अ गिवन टेम्परेचर एंड प्रेशर. इज इट ओके? अभी कभी कभी क्या करेंगे ना, सिर्फ दे विल बी चेंजिंग द, दे विल बी कीपिंग द मोल्स कांस्टेंट एंड एवरीथिंग एल्स विल बी चेंज्ड. If that is the situation coming, it doesn't have any name, but the relation says if you again keep PV equals nRT, so if everything else is changing, that means P, V and T is changing, and if you are keeping N and R constant, R तो already constant है, then P into V upon T is becoming constant. So we are saying P into V upon T is constant, and that constant is nothing but, if you see, it is NR. Is it okay? Any doubt? No, इन सारे लॉज के जो क्वेश्चन होते हैं ना, मोस्ट ऑफ द टाइम दे विल नॉट गिव यू द आइडिया कि ये मैं इस लॉ का क्वेश्चन पूछ रहा हूँ. यू हैव टू आइडेंटिफाई बाय द लैंग्वेज. सो आई वांट टू आस्क यू सम ऑफ द क्वेश्चंस. यू हैव टू आइडेंटिफाई क्या कांस्टेंट रखने का, क्या कांस्टेंट नहीं रखने का. इट मे बी अकॉर्डिंग टू अ नेम्ड लॉ, इट मे नॉट बी अकॉर्डिंग टू अ नेम्ड लॉ, बट वी हैव ऑलवेज गॉट द पीवी इक्वल्स एनआरटी, है ना. तो जस्ट ट्राई करो, कुछ क्वेश्चंस दे रहा हूं मैं, बट इफ यू हैव एनी डाउट जस्ट आस्क मी फर्स्ट, because then I'll ask you the questions. You have any doubt? सब लोग वीडियो ऑफ करके भाग गए. स्विच ऑन योर वीडियोस.
No, sir, no doubt.
स्विच ऑन योर वीडियोस. क्यों ऑफ करने का भाई वीडियो? कितने प्यार से समझ रहे हो तुम लोग. चलो फिर, if you don't have any doubt, then I'll ask you the question. Start solving. This chapter is about numerical questions. कहीं कहीं concepts we are going to discuss, but most of the time you'll be seeing that we are going to solve some questions on it. Try करो ये question जरा. See, ऐसे क्वेश्चंस में if they have not mentioned ना, तो वी हैव टू मेक सम assumption and that assumption is टेम्परेचर की बात कहीं नहीं की है, तो वी हैव टू assume टेम्परेचर टू बी कांस्टेंट. नहीं भी रहेगा तो वी हैव टू कीप इट, बिकॉज उन्होंने कुछ चर्चा ही नहीं की है व्हाट अबाउट टेम्परेचर.
So 2 millimeters.
Okay. Okay. Vivan has also got the answer.
हाँ सर 2 millimeters.
Okay. बाद में मैं पूछूंगा टेल मी द डेप्थ ऑफ द लेक. Okay, so basically if you see, if I'm having a bubble, na, if I'm having a bubble, always focus on what is not changing. What is not changing? Obviously temperature is constant. If I'm having a bubble, T already दे दिया है constant, but what else is not changing? Hmm? सॉल्व किया है तो ये तो assume किया होगा ना what is not changing, what is
Temperature and
Temperature.
and moles is temperature तो लिख दिया मैंने, moles is not
सर
changing.
moles
gas,
भी.
gas is trapped inside it, है ना? And that's why in a closed volume we are saying if there is no leakage, obviously bubble नीचे से ऊपर आया बिना फूटे हुए, तो definitely the volume was closed. So in a closed space always you will see that कि moles are constant. And जैसे ही n और t constant हुआ, we know that P1 V1 equals P2 V2. And that says bottom पे जो pressure था that was 6, V1 will be 4 by 3 pi R1 cube. I am writing it. Will be equal to, या फिर I'll write it P1 only. बाद में इसको change कर देंगे. P2 into 4 by 3 pi R2 cube, क्योंकि volume लिखना है, radius से directly relate नहीं कर सकते. And that's why I'm getting R2 is equal to P1 by P2 raised to 1 by 3 into R1 आ जाएगा. And P1 by P2 if you calculate ना 6 by 0.75 ये सब number set करके दिया था. This is coming 8 raised to 1 by 3 into 1 mm. And 8 raised to 1 by 3 is 2. So this is 2 mm will be the answer. Solve this one.
Sir, 400 Kelvin.
127 degree.
ओके, अभी जस्ट मैंने सिखाया था एक चीज, व्हाट इज बीइंग आस्क्ड, यू नीड टू बी वेरी केयरफुल. It is asking temperature, but it is not asking the temperature in Kelvin. It is asking it in degrees C, है ना? So that's why पहली बात, balloon है, balloon का मतलब flexible volume है. If you are having a flexible volume, then you can't keep the volume constant even if it is closed space, but moles are still constant, है ना? So this time it says to what temperature the balloon can be safely heated at constant pressure. So this time we'll say N and P are constant. These things are constant, and that's why we'll be saying V1 by T1 is equal to V2 by T2. And now if it is asking you T2, that will become V2 upon V1 into T1. Now it says final लेकर जाना है maximum stretching volume तक. I'm writing that as V max, and initially it was only 3 by 4 of V max. That much into T1 was 300 Kelvin. Because यहाँ पर हम लोग टेम्परेचर को हमेशा केल्विन में लेंगे, and that gives you that we are getting 400 Kelvin as T2, which is 127 degrees C, and this will be the answer. Okay, give me the answer of this question.
Sir, T is negative 173 degrees Celsius.
Okay. वॉल्यूम यू कैन रिपोर्ट इन लीटर. हाँ, वी लीटर ही लिखा है ना, तो लीटर में ही बताना है, वी का है.
The temperature 100 degrees Celsius.
Okay, we have got two answers, 100 and minus 173.
So 0.821.
Okay. So I told you कि we don't have to always identify the which law we are talking about. Just see PV equals nRT, it will always give you the answer. And when you are applying PV equals nRT, we have to apply it in two situations. Initially, we were having 1 atm pressure when volume was V liter. We don't know how much we have to calculate that. but it was having 12 gram ideal gas, which is having molecular mass 120. So this is the mole into R into temperature was given in degree C. So that much plus 273 will be actually the temperature in Kelvin. Hai na? So this is one equation which says V is equal to R by 10 into T plus 273. This is equation number one. Now the second situation is, this is initial, and final condition says that when temperature is increased by 10 degrees C at the same volume, then we are getting the pressure equal to pressure ka increment 10%. So we'll be saying 10% ka increment matlab 1.1 ho jana. This much into V is equal to, this is also same, into R into, this time it will be 10 plus T plus 10 plus 273. Hai na? And then if you simplify it, we are getting 1.1 V is equal to R by 10 into, this time we have got T plus 283. So this is equation number 2. 2 by 1 kar lo. है ना? If you apply 2 upon 1, we are getting 1.1 is equal to T plus 283 upon T plus 273, and that says 1.1 T plus, this will become 273 plus 27.3, so 300.3
300.3.
is equal to T plus 283, and that says 0.1 T is equal to, this is 17.3, and that's why T is coming 17, sorry, minus में ना,
Sir, minus होगा.
minus में आ जाएगा. So this is the answer for T, which is in degree C. If you calculate it in Kelvin na, then you will be getting 100. किसका 100 आया था? I think that was the mistake. Was that the mistake?
हाँ sir.
है ना?
100 आया.
So we need to be very careful क्योंकि मैंने यहाँ T को डिग्री C में लिखा हुआ है ना. Start में it is written here that it is in degree C T. Kelvin में it is T plus 273. That's the value you have got, है ना? So that's one part. Now if it is asking V, किसी एक equation में रख दो. In equation 1, you just write
Sir,
V
0.821 है.
हाँ, 21 upon 10 into T plus 273 will become 100 m, and that's why this much liter में ही था value, है ना? So that was 0.821. It is the answer for B. I'll give you one more question and then we'll move to graphs का idea है तुम लोगों को, straight line, parabola, hyperbola, that much you
Yes
know?
sir.
Okay, chalo good. So solve this question and then we'll move to the graphs related to ideal gasification.
Sir, 200 Kelvin.
Okay, you're saying Kelvin,
Yes, sir, Kelvin.
but if you see the language, it says it is heated. Are you expecting the final temperature to be less than the initial? There can be two things. या तो तुम wrong या तो language is wrong, because it is talking about that it is being heated. है ना?
अच्छा सर, 1 मिनट गलती होगा कैलकुलेशन में.
Okay.
Sir, 450 Kelvin.
Okay, I'll wait for other people also.
Sir, 450 Kelvin.
Ajay?
450 Kelvin.
Okay. Now if you see, we are having open vessel. Whenever we have got open vessel, understand that the pressure is constant. Why we are saying pressure is constant? Because any point, any thing which is in contact with atmosphere is said to have the pressure equal to atmospheric pressure. So यहाँ से जैसे ही open vessel लिखा, we'll say pressure is constant and that too is equal to atmospheric pressure. In future, and this is going to be case in the chapter of thermodynamics, if they are using atmosphere open container they are mentioning, then we'll be saying that atmospheric pressure is the pressure of the gas inside that container. And wo ho gaya. And now this time moles is not constant if I'm taking the container as a system, hai na? If this container is my system, then all the moles are not remaining in the container. So देखो, in future भी you'll see that na ki we have to always understand when I'm considering some system, I need to see that I'm considering mass as a system or I'm considering the volume as a system. So this time it is convenient to take the system volume as the system. If I'm having this volume as the system, then moles is not constant. Then we'll say moles is not equal to constant, but P is constant and V is constant, है ना? And by that we can say N into T is constant, PV equals nRT. This is constant, which means अब ये देखो कोई named law नहीं है, ये किसी scientist ने ये law नहीं दिया, but once we know that PV equals nRT, so we can write any relation based on our understanding, and that's why we can say T2 is nothing but N1 by N2 into T1. And now it says 1/3 has been expelled. That means the remaining 2/3 is there, है ना? That's why we'll say initial अगर N1 था, तो this is 2N1 by 3 into T1 is 300 Kelvin. And that's why if you calculate this value, we are getting 450 Kelvin. And that will be the answer. Because it is not specifying any unit. You can also convert that into degree C. That depends on कि पूछा क्या specifically वहाँ पे. So 450 will be like 177 degrees C. Is it okay? Chalo, let's go to graph. Are you all assuring me ki you know the graph, particularly straight line, parabola, and hyperbola? Anyone
Yes,
have?
sir. So can you repeat why N into T is constant?
See, if you are taking the container as a system, है ना? Now, what is not changing? Is the pressure changing?
No, it's not.
It is an open container, है ना? That means
Yeah.
pressure will always be atmospheric pressure. Is the volume changing?
No.
Now, if you see the PV equals nRT, pressure is not changing, volume is not changing. That means P into V is constant.
Yeah.
Upon R is also constant. That means the remaining part is N into T.
Yeah.
है ना?
Okay. Yeah, I got it.
That's why N into T is
Okay,
constant.
that way. I got it.
Because this constant is nothing but, if I write it here, it is nothing but P into V upon R, and everything in bracket is constant. है ना? Okay, so now, so I'll just be moving to the graphical type of question. I'll ask you to draw some of the graph in qualitative way. You don't have to care of the scale. Now, see, this question will be called the question from the Boyle's law because I am keeping the temperature and moles constant, है ना? But if whenever I'll be keeping some temperature constant, na, the graphs will be called isotherms. Okay. Now I want you to draw these 6 graphs in qualitative way. And you have to tell me the name of the graph, like whether it is straight line, parabola, hyperbola, kya hai ye? And you have to see the pattern also. Right now, you just tell me the name and the nature of the graph, whether it is increasing or decreasing. Okay? Name and nature, decreasing, increasing, constant. That's all. Or if it is a straight line, whether it is passing through origin or not. Is it having positive slope or negative slope? These are the things we talk about a straight line graph, whether it is a horizontal line or a vertical line. That is also a possibility. Yeah? So let's handle first four. तो पहले A वाला देख लेते हैं. Now in all these cases, now we are saying temperature is constant. That means P into V, which is equal to nRT, is constant. Now, whenever they are asking you ना something versus another thing, that versus के पहले वाला something की जगह you write y, and versus के बाद वाला another thing की जगह you write x. That's the way you will be identifying the nature of the graph. Okay. So now in first case, it is asking P versus V. So for P versus V, here we have to take P, here we have to take V. Now if you see, we have got y into x equals constant, and that constant is positive, and RT ka value is positive, which means y is equal to that constant. या तो एक काम करो ना, मैं जो constant है उसको लिख ही देता हूँ so that you have the idea. So y is equal to nRT, which is a constant, upon x. कैसा ग्राफ होगा ये? What type of graph we are expecting?
तो ऐसा डाउन, ऐसा पैराबोला बनेगा ना,
इसको
डाउनवर्ड.
पैराबोला नहीं बोलते हैं. y is equal to some constant upon x or x square or x cube, ऐसा कुछ आ जाए ना. This is called hyperbola. Okay, we need to know the name. Sometimes they'll be writing it in English that this graph will be a hyperbola, this graph will be a parabola. ऐसा लिखेंगे वो. तो whenever we are getting y equals some constant upon x ना, it is a rectangular. To be more specific, it is called a rectangular hyperbola. Simply hyperbola भी बोलोगे तो चलेगा, but hyperbola का बहुत ही general equation अलग होता है, but it is one of the special case. तो यहाँ पे this graph will be looking like this. ऐसा कुछ चलेगा ये. ठीक है? This is a hyperbola. Is it okay, everyone?
Yes.
Second में पूछा है P versus, I'll write all the terms. P versus 1 by V. C में पूछा है PV versus V. And fourth में पूछा है P versus PV. Okay, tell me the second one.
A straight line passing through the center.
ओके, यहाँ पे लिखा था PV इक्वल्स nRT एंड P की जगह y एंड V की जगह x लिखा था. दिस टाइम वी कांट राइट V की जगह x. वी हैव टू राइट P into V equals nRT. Obviously that was the relation we have used, but that says P is nRT by into 1 by V, and now this time y axis pe we have got 1 by V, and that's why we need to write y is equal to nRT into x, and that is straight line passing through origin, है ना. with positive slope because nRT का value is positive. So this is straight line passing through origin. Is it okay? And that's why the graph का nature will depend. Niranjan, is it your audio?
Sorry, sir.
Okay, if I ask you the slope, can you tell me the slope of this graph? If I say this is theta, can you tell me how much will be tan theta? Because whenever we'll be having straight line graph, na, most of the
NRT.
time it is nRT, na? Okay, next graph. Third graph बताओ.
Sir, horizontal straight line.
Because this time they are saying PV को y axis पे रखना है. That means we have to put PV की जगह y, and that is equal to nRT, which is a constant. Y equals constant is a horizontal straight line or straight line parallel to y x axis, है ना? So this is horizontal straight line, and that's why the nature of the graph will be like this. Is it okay? And this value is nothing but nRT, na? This will be nRT के बराबर. Okay, last one. Fourth one. P versus PV. Now, if I'm writing PV equals nRT, that means this time PV is on the x-axis. So we'll be writing x equals nRT. Na? What type of graph we are expecting? Anyone?
The
What type of
vertical
graph?
straight line.
Or this is vertical straight line. Na? X equals constant का मतलब है it is a vertical straight line. And that's why the graph will be looking like ऐसा दिखेगा. This is 90 degree. This is 90 degree. Okay. चलो D and F भी कर लेते हैं. D is log P versus log V. D. I'm having log P versus log V. What to do now?
Sir, we will take log on both sides.
So we have got PV equals nRT. Take the log of it. So we'll write, and log P into V will become log P plus log V. Na? Log A into V is log A plus log V. And that's why we are getting log nRT. Which means log P is equal to minus log V plus log nRT. And if I am keeping P की जगह log P की जगह y, तो we are getting y equals minus x plus this term log nRT. So we are getting straight line, वो तो पता है. What is the slope of the graph? This is straight line with slope equals how much?
-1.
-1, है ना? That means it will be making 135 degree angle from the x-axis, है ना? So if I'm keeping that straight line, can you tell me the y-intercept now? That's important. Will it be positive, negative, or zero?
Positive.
And why is that? Why are you saying
Current
positive?
y-intercept x equal to 0. So y is log nRT, which is positive.
Just see log nRT का value if I want to get now. So I have given you the condition, and that condition was in any unit if you are taking ना, मान लो मैंने ले लिया ATM liter वाला unit, then 1 mole, this is 0.0821 into this T is 25 degree से लिया था, and we know that value. So this is log 24.46. log 1 से ज्यादा रहे ना तो फिर वो पॉजिटिव हो जाता है ना. That's why we are saying कि it will have a positive y-intercept, but it has got a negative negative slope, and that's why if I'm trying to draw the graph, I'll be getting a graph like this. Now, if it is asking what is the slope of this angle is 135 degree. तभी तो tan theta is -1 है ना? And this value is log nRT. Last one, P by V versus 1 by V. E graph. Can you tell me the nature of the graph first? Anyone? Just apply the mathematics. It will tell you the answer. We have PV equals nRT. आज के दिन तो यही है. We have P into V is equal to constant, that constant is nRT, which means P is equal to nRT into 1 by V, but we have to keep P upon V. P upon V ऐसे नहीं आएगा. We have to divide it by V है ना? And once you have divided it by V, we are getting nRT into 1 by V का whole square है ना? And that's why we are keeping P by V की जगह Y and 1 by V की जगह X, and that becomes X square. What type of graph it is? It is a parabola. Okay, which means if I have to draw this graph, I'll be getting, sorry, I'll be getting a graph like this, है ना? So this is a parabola. तो parabola में तो slope is changing at every point, so we don't talk about that. But it will be upward. If it is nRT was negative ना, मान लो अगर होता, यहाँ तो हो ही नहीं सकता है, because temperature is always positive in Kelvin. But अगर y equals -2x square आ जाता, then graph will be like this, ऐसा हो जाता. ठीक है? So for your reference, I'll be giving you different type of graphs, and I'll be giving you some questions also based on the graph. Next time तुम लोग करके लेके आओगे. So I'm just giving you for a reference कि whenever you need these type of graphs ना, and ready-made already I'm having these graphs जो कि बहुत ही frequently use होते हैं तुम्हारे पूरे syllabus में. Extra graphs will also be coming, but whenever it will be coming, I'll tell you what type of graph it is. But in general, I have given you straight line, hyperbola, particularly rectangular hyperbola, and then parabola का graph. ये सब दे दिया मैंने. Now I'm giving you some homework questions. ठीक है? So like,
can you show the P by V versus 1 by V graph?
okay, 1 minute. I'll show you. Where is that? Yeah, this one, no? Okay. Sure. So now I'll be giving you some homework questions. Try these questions, and then when we meet ना, तो फिर
सर आइसोकॉर्स का मतलब क्या है?
Volume constant. If volume is constant, it is called isochore. And one more question I'll give
So are
you.
you sending this sheet on the WhatsApp
Yeah,
group?
yeah.
All right.
I'll be sending you this whole PDF on the WhatsApp. Okay.
All right. Sir. Thank you.
There is one more question. This is the question. Okay. These are the homework questions. You have to do it, and then next time when we meet, पहले तो Saturday का lecture will be based on the periodic properties, and Monday का lecture will be on the gas state. So you have got 7 days, है ना? So solve these questions, and then when we meet ना, तो फिर आगे बढ़ेंगे, and we'll be talking about if I'm having connecting vessels, then how to solve the problem related to that, and then we'll be talking about liquid column and then barometer, manometer. उसके बाद फिर we'll move to the next topic, which is called Dalton's law of partial pressure. Okay. So keep revising mole concept, try these questions, and then we'll meet. है ना? Okay, ठीक है. Bye everyone.
Thanks, sir.
बाय सर, थैंक
2.5 hours right रहा था ना? Was it a right length? ऐसा तो नहीं लगा बहुत ज्यादा हो रहा है? Vivan, what's your status? कैसा था ये, मतलब 2.5 hour was bearable?
Yeah. Yes, sir.
Okay, okay,
Yeah, I understood everything. Sir.
okay. चलो good. Okay. तो periodic वाला issue इधर नहीं आ रहा था ना अभी right now gases में?
What, sir?
Periodic में you are having some issue ना कि पुराना नहीं आ रहा था इसलिए you are
Yeah.
having less understanding.
Yeah.
This time you are okay ना? Because
Yeah.
this was the start of the chapter. Second
Yeah.
thing is, have you revised those periodic table wala chapter?
I was starting the time over the weekend. I had a lot of tuitions.
Okay, not a problem. But revise that before the next lecture, है ना?
Yes, I'll try.
Okay. Okay.
I just ask Vimy Miss for the lectures playlist.
हाँ जी.
I'll ask Vimy Miss for the lectures ka playlist.
But I have sent it in the group. Oh, you were added today only?
I'm not there in the group.
Okay. I'll send it to her and she will send it. Okay. Okay.
Thank you, sir. Bye.
Okay. Bye bye. Udyan, Siddharth, anything else you want to say?
Thank you, sir.
Okay.